Hi, welcome to this video where we're going to look at various fraction models and how to introduce them to students. You may already have a set of fractions available to you like these, and they're a great resource for teachers because they're made of good sturdy materials and you're not going to break them, and they'll last a long time when working with students. But really, students need to make their own models and be familiar with the whole and the fraction parts themselves. So keep this as a great resource for you to use, but for the students, they really need to be developing their own. Now, there's 4 different types of models that students should become familiar with when dealing with fractions. The first is an area model. So your shapes, your pieces of paper, anything that we could find in the area of are our area models. We then have our fractions of collections. So whether it be collections of counters or matchsticks, whatever you have available to you in the classroom. One that we don't tend to necessarily use as frequently are our volume models. So using things like your measuring cups to show the relationship between 1 cup and a quarter, perhaps using rice and kinetic sand for those. And then finally, we need a linear model, a model on a number line, for instance, to show fractions as well. So let's start by having a look at our area models. When we're doing fractions with students, one of the things that's important is to always represent the whole and have it there for students to see. What I mean by that is often if we give them representations of models, such as a rectangle that's been partitioned and they shade a half of it, they may lose sight of the original whole, the original rectangle. So I recommend having the whole always there so that they can see the relationship between their fractional part and the whole itself. With area models, what we want students to see is that even though the fractional part may look different, that they can still be a half. In other words, this is a half because it is one of 2 equal parts. I folded my rectangle into 2 equal parts, and one of those is the half. But likewise, I could have folded along the diagonal, and this is why I use rectangles rather than squares, because they really show the difference in appearance. But even if I cut along this diagonal, it will still be a half. But students will often find it quite confronting to think that this half is the same as that half. But because we started with the same area and we've folded them or partitioned them into 2 equal parts, they are a half. The other thing that models can help students see is that it depends on our original whole. So where we had a whole and these were both halves, we could have a different whole and our half will be different. And this is important for students to see. So that's why it's great to have the whole always represented rather than taking the whole and partitioning it into fractions where they can no longer see the whole. For instance, both of these, we can't see the original whole anymore. But what they need to see is that a half of this whole is still a half, even though it will be different in size to a half of this whole. And that's because a half is 1 in every 2 equal parts. Using these strips of paper, we can link to our linear models for students. So if we take our whole and we draw a line underneath, we can start a number line of 0 and 1. And our whole represents that space between 0 and 1. Students then take another strip, fold it in half, they can glue it down, they can cut it if they prefer, but we're going to watch the language that we use. Now, it's important for students to first become familiar with fractions in terms of the words they use, because the number representation of a half can often lead to misconceptions or some confusion for students. What they see when they see 1/2 represented numerically is two different numbers rather than a single number. And unfortunately, we can sometimes reinforce this by introducing them to concepts such as numerator and denominator too early. When we talk in terms of numerator and denominator, they can think of a fraction as two different numbers. And so when we ask them to compare a half and a quarter and ask them which one's bigger, they're often drawn to the quarter because they see the 4. The ones are the same, they know 4 is bigger than 2, so they think that a quarter is bigger than a half. What they need to see is that represented on a number line. So certainly you can introduce the numbers. I know it's going to be hard not to, the numerical representation of the fraction, but certainly talk and use a half, the words a lot as well as the description, 1 in every 2 equal parts. Now, once students have partitioned this into their halves, folded it, they can continue the dotted line down to where they can label the half. So this is 1/2 because it's the end of the half, the first half, and at number 1, we have 2 halves. So we're starting to build up equivalence between 1 whole and 2 halves. You can include the numerical there as well. You could go on to thirds. I tend to go to quarters next and start building that relationship up. And again, we could come down, label 1/4, 2/4, and so on. So we're now creating a number line model of our fractions as well as the area models. And that enables students to compare numbers like this, fractions like this, by using their number line, as well as the physical size of the fractions. If they've cut their quarter, they can see that a quarter is physically smaller than the half. So that's the number line model, and connecting it to the area model of fractions. The next model is the collection model, and it's another difficult concept for students to get around because the number of counters here is what determines the whole. And we can find it harder to see something like a quarter when we've got a collection of 6 items. So you might want to choose carefully when you're thinking about your whole, the numbers that you're going to choose. But we might start with our whole here of 8 counters. And if we want half of those to be represented, we could turn them over using our double-sided counters, which are a fantastic resource to have in the classroom. We'd want to see if students see a different representation, perhaps one like this, as to whether that is also a half. And we can see that a half is 1 in every 2, so we could have also represented it like this, where you're seeing the 1 in every 2. So giving students a mixture or a variety of fraction models is an important thing to do to build up their full understanding of fractions. We can't rely totally on the area models, the colouring in of shapes and so on. We need to connect all of these to really show the students how fractions can be modelled. And of course, don't forget your volume models as well. I hope you've enjoyed this video. Please leave us a review or post any questions that you have, and hit subscribe to see our future fraction videos for this week. Thank you.